Okay, welcome back to the deep dive. So let's kick things off with maybe a slightly uncomfortable question, something you probably try not to think about too much. How do you actually know if one of your internal organs is, well, silently deciding it's had enough,
Yeah.
before it's really too late?
Yeah, it's one of nature's crueler tricks, isn't it? This whole delayed notification system.
Mm,
Our organ, they're just masters at hiding problems.
right.
Think about the liver. You get almost zero warning signs until the damage is, well, pretty extensive. And heart attacks. I mean, tragically, the first symptom is often the attack itself.
Yeah, I heard it's like over half the time the very first sign is, well, the final one.
Exactly. It's sobering. And we tend to think, our bodies will send us a memo if something big is going wrong.
But the brain, that seems like the ultimate master of compensation.
Oh, absolutely. It spends decades, literally decades, kind of sweeping neurological junk under the rug, compensating for cells that are failing, rerouting signals, until one day, poof, the rug's full, the system can't cope anymore, and suddenly the symptoms are impossible to ignore.
And that's why things like dementia feel so terrifying, right? It's not like you just wake up with it one morning.
Not at all. That process has likely been running silently in the background for 20 years or more.
Okay, let's unpack this then. If there's pretty much no obvious early symptom, no like brain fog, check engine light, how do we get a jump on it? Well, surprisingly, the answer might not involve a fancy brain scan. It might involve looking at the only bit of your nervous system that actually sticks out of your head.
You're talking about the retina.
Exactly.
It's fascinating, really. The eye isn't just for seeing. It's literally an accessible window into your central nervous system.
Yeah.
And we're seeing this really strong correlation now between specific measurable issues in the outer layer of the retina and the very, very early stages of trouble brewing deep inside the brain.
Wow. So the retina, it's like the canary in the coal mine for your brain's future. But what are we actually looking for? Because, let's be honest, most of us see an eye doctor when things get blurry, and they usually just say, yep, you're getting older, here are some stronger glasses.
And that's the crucial difference we need to highlight for you. This isn't about standard vision changes or just needing reading glasses. Researchers are looking at specific structural changes, things you, as the patient, might notice but probably dismiss.
Like what?
Like having trouble seeing subtle differences between shades of gray, or maybe colors don't seem quite as distinct. Issues with night vision that seem worse than usual. Problems with your central vision, maybe more floaters, or being really sensitive to light.
Okay, wait. If I suddenly see more floaters or can't read the menu in a dim restaurant, my first thought isn't, oh dear, early cognitive decline. My first thought is usually, ugh, getting old sucks. Or maybe, need new glasses.
Exactly. And that's why getting this information out there is so important. It's easy to brush off. But the key insight here is the why. It turns out that the same gunk, the amyloid-beta plaque, that sticky protein garbage that messes up brain communication, well, it can actually build up directly on the retina.
Seriously.
The same plaque.
The very same. So when scientists use specialized imaging, like OCT scans, they can see specific patterns, thinning in certain areas or plaque deposits, and they can see this years, sometimes many years, before major cognitive symptoms show up. It's a measurable signal.
Okay, that is genuinely mind-blowing.
Yeah.
The plaque tour starts at your eyeball.
But hold on, because here's where it gets even weirder, or maybe more connected. If we're checking eyes, should we also be checking our teeth? It sounds like a bizarre health combo, right? Eyes and teeth?
It might sound strange at first, but absolutely.
Mm-hmm.
There's a solid physical connection. It boils down to inflammation and specific bacteria.
Mm-hmm.
When researchers looked at the brain tissue of people who had Alzheimer's, they consistently found high levels of a particular microbe, a pathogen. And it turns out this specific bug, often P. gingivalis, is a common resident in your mouth,
Yeah.
especially if there's dental infection or gum disease, periodontal disease.
So hang on, you're saying bacteria from my gums can get into my brain and contribute to Alzheimer's plaque?
Precisely. Think of severe gum diseases creating little leaky gateways. This pathogen gets into the bloodstream, travels around the body, systemic inflammation, and yes, it can cross the blood-brain barrier. Once there, it contributes to the whole inflammatory mess and plaque formation.
Wow.
So if you're trying to tackle brain inflammation, you absolutely have to address any underlying infection in the mouth first. It's a primary source.
So that regular dental checkup suddenly feels a lot more important than just avoiding cavities.
Oh, definitely. And just to add another layer, this same bacteria from the mouth, it's also been found in the plaque clogging up arteries in the heart.
Okay, so the mouth is basically ground zero for a lot of chronic inflammation issues.
It can be a major gateway, yes. Your gum health is intrinsically linked to your systemic health, including your brain.
Right, so maybe one of the best preventative things you can do is just floss and see your dentist. Seems almost too simple.
Simple, but fundamental.
Okay, let's switch gears a bit. We've talked about inflammation sources, but how does the brain actually clean up this mess? If it's getting dirty and inflamed, does it have its own, cleaning crew?
It does, but it's not like the rest of the body. The brain doesn't have a standard lymphatic system, those vessels that drain waste elsewhere.
No lymph nodes in the brain.
Mm.
Got it. So if it's like a messy room filled with, I don't know, old wrappers and protein bits, how does it tidy up? Does it have tiny Roombas?
Huh. Not quite Roombas, but maybe more like a highly efficient dishwasher. A dishwasher that, crucially, only runs its main cycle at night. We call this the glymphatic system.
Lymphatic, okay.
Yeah, it uses the brain's glial cells and the channels filled with cerebrospinal fluid. And here's the really cool part. During deep sleep, your brain cells actually shrink. They can shrink by up to 60%.
Whoa, 60%.
Yep. This opens up more space between the cells, allowing that cerebrospinal fluid to flush through much more effectively. It literally washes away the waste products, pulls out those misfolded proteins, the amyloid plaque. This cleaning process is a core fundamental reason why we need deep, high-quality sleep.
That is incredible. So the entire cleaning mechanism hinges on you getting proper rest.
Absolutely. Anything that messes with that deep sleep cycle that prevents the shrinking and flushing, it directly increases your risk.
And we know generally that less than 6 hours of sleep is bad news, right? Linked to heart attacks, strokes, cancer, diabetes.
All of those, yes.
Right.
And Alzheimer's is definitely on that list. But the impact is shockingly immediate. There's research showing that even one single night of getting less than 7 hours of sleep results in about 50% more amyloid-beta plaque buildup in the brain compared to a full night's rest.
50% from one bad night. That's
Yep.
brutal.
It is. You're basically leaving the dishwasher half full of dirty plates overnight. You incur that biological debt instantly. The glymphatic system just didn't get enough time to run its full cycle.
So the goal isn't just getting some sleep. It's getting enough quality sleep, like 8, maybe even 9 hours.
8 or 9 hours seems to be the sweet spot for most adults to allow that full cleaning cycle to complete. Think of the recommendation from books like Why We Sleep.
Okay, that 50% number really puts it in perspective. Missing sleep isn't just making you tired. It's actively letting junk pile up in your brain. So what's the biggest enemy of this deep clean cycle? What sabotages the glymphatic system most effectively?
Well, a really big one is alcohol.
Ah, the nightcap.
Exactly. Alcohol feels like it helps you sleep because it's a sedative, knocks you out.
Mm.
But it drastically suppresses REM sleep and deep delta wave sleep, the very stages the glymphatic system needs to do its best work.
So it helps you pass out, but it stops the actual cleaning crew from showing up.
Pretty much. Just one drink, like one glass of wine, can significantly fragment your sleep and reduce the quality of those essential deep sleep stages. You're actively hindering the cleanup.
Wow, okay. That helps me unwind. A glass of wine might be doing the opposite for brain health long term.
And it gets worse.
Yeah.
If you're drinking regularly, several times a week,
Yeah.
it's not just about wrecking your sleep architecture. Alcohol can also significantly suppress your body's production of growth hormone, sometimes by as much as 50%.
50%. Growth hormone is key for repair and anti-aging, right?
Absolutely. So you're trading short-term sedation for less brain cleaning and less bodily repair. It's a really bad deal biologically.
Yikes. Okay, that definitely puts the whole nightcap idea in a much darker light. So if sleep is the essential night shift cleaning crew, what about the day shift? What's the regular maintenance that keeps the brain running well?
There would absolutely be exercise. Regular, consistent physical activity.
Okay, how does that work for the brain specifically?
Well, one of the brain's biggest enemies is lack of oxygen, or hypoxia. Exercise does the opposite. It floods the brain with oxygen-rich blood. This helps combat inflammation and gives neurons the fuel they need. Think about it. If you're sedentary, you're kind of slowly starving your brain of optimal oxygen levels.
So less hypoxia, more happy neurons.
Exactly. And exercise does more than just deliver oxygen. It literally makes the brain environment healthier. It stimulates the growth of new brain cells, especially in areas related to memory, like the hippocampus. And critically, it boosts the production of something called BDNF.
BDNF, brain-derived neurotrophic factor. I've heard of that.
Right. And the best way to think about BDNF is like miracle grow for your brain.
Ha! I like that. Miracle-Gro.
It really is. It helps existing neurons survive, encourages new connections, improves signaling. It's vital for plasticity and health, and you can't just pop a BDNF pill. You have to earn it through movement.
Okay, so exercise is brain fertilizer. Got it. Now, you mentioned sleep rhythm earlier being super important for that glymphatic cleaning system. And there's this tiny little clock mechanism deep inside the brain, right?
The suprachiasmatic nucleus, or SCN.
Yeah.
But yeah, you don't need to memorize the name.
Right, the SCN. This little clock needs to be set correctly. How do we do that? How do we reset our internal clock effectively?
The most powerful cues are environmental, especially light. You want lots of bright light, preferably natural sunlight, during the day, especially in the morning. That tells the SCN, hey, it's daytime, be active.
Yeah.
And then, just as importantly, you need to reduce light exposure in the evening as it gets dark. Dim the lights, avoid bright screens. That signals, okay, time to wind down, prepare for sleep, get the cleaning crew ready.
Makes sense. Light on, light off, basic stuff.
Basic but powerful. And another tool, particularly if the rhythm is really off, can sometimes involve vitamin D.
Oh, yeah, you mentioned a high dose, like 20,000 IU. That sounds like way more than the usual recommendation.
It is significantly higher, and that's an important point. We're not talking about a daily maintenance dose for everyone forever. That kind of level, usually based on blood tests showing a significant deficiency, might be used therapeutically for a period. The idea is to use it to help reset those neurochemical pathways involved in sleep regulation and synchronizing that SCN clock. Vitamin D acts almost like a hormone regulator in this context.
Okay, so it's more of a targeted reset strategy, not a casual daily thing for most people.
Correct. Always best to work with a healthcare provider on dosing like that.
Good clarification. All right, maintenance covered. Let's talk fuel. What should we be feeding this incredibly complex, delicate engine? You hear a lot about sugar being bad. If your diet is mostly carbs and sugar, what's that doing to brain cells?
Well, over time, it can actually lead to a form of starvation for the nerve cells. As insulin resistance develops, the brain cells lose their ability to efficiently use glucose, their primary fuel source. So even if there's sugar available, they can't really take it in properly. It leads to inflammation and energy deficits.
Starving in the land of plenty. So what's the alternative fuel?
The brain loves ketones. They're a much cleaner, more stable, and more efficient fuel source, especially for aging or stressed neurons.
Ketones, like from a ketogenic diet.
Exactly. The simplest way to get your brain using ketones is to significantly lower your carbohydrate intake. This pushes your body to produce ketones naturally.
What about for someone who's maybe already showing some signs of cognitive issues? Is there a faster way to get ketones to the brain?
Yes, definitely. In those situations, using ketone supplements directly can be beneficial, and also regular use of MCT oil, medium-chain triglycerides.
MCT oil. Okay, how does that work?
MCT oil is unique because it gets converted directly into ketones by the liver, pretty much regardless of your diet. So it provides a quick, direct source of that clean ketone fuel that can bypass any issues with glucose metabolism and feed the brain cells immediately.
Interesting. Like a direct fuel injection for the brain.
Kind of, yeah.
Okay, any other specific nutrients we should be thinking about beyond the basics?
Niacin, which is vitamin B3, is really important.
Niacin, why that one specifically?
Because it's absolutely essential for energy production within the cells. It's a key component in making ATP, the actual energy currency the brain runs on. Without enough niacin, the fundamental energy pathways in the neurons just can't function optimally.
Makes sense. How much are we talking?
Well, you have to start slow with niacin because of the flush effect. Maybe start with just 50 milligrams. Then you can gradually increase it, maybe to 100 milligrams daily, and potentially work up towards 500 milligrams over time, depending on tolerance.
Ah, yes, the famous niacin flush, where you suddenly feel like you're on fire, red face, itchy.
Yes. It can be intense.
Just to reassure listeners that flush isn't dangerous, right? It's just blood vessels opening up.
Exactly. It's vasodilation, which is actually good for circulation. But it
What?
feels dramatic, so definitely start low and go slow to let your body adapt.
Good advice. Okay, so let's try and tie this all together. What does this all mean? We started out with this kind of scary idea that the brain fails silently, but it sounds like there are potential early warnings, just maybe not where we expected, like in the eyes.
Precisely. The earliest structural signs might be visible in the retina, that window to the brain. And a huge potential driver of the inflammation that causes problems might be starting somewhere as mundane as your mouth, with gum disease.
And the brain's entire cleaning system, the glymphatic system, relies almost entirely on getting enough high-quality sleep.
That's the core takeaway, really. Prevention isn't necessarily about some complex future tech. It's about consistently mastering the fundamentals. Deep sleep for cleaning, regular exercise for oxygen and that miracle grow BDNF, and giving your brain the clean fuel it prefers, like ketones, instead of overloading it with sugar.
So ultimately, that slow decline isn't maybe inevitable, it's heavily influenced by our daily habits. Which leaves us with a final thought, maybe something to ponder. If your brain's cleaning crew only works properly when you're deeply asleep, and things like alcohol actively sabotage that cleaning time, cutting it short, are you really resting when you have that relaxing drink before bed? Or are you just slow-mo, slowly, night after night, accruing a cleaning debt that your brain might eventually not be able to pay back? Something to think about tonight.